Hi everyone, I'm Victor Francisco from PSC Consulting. With me here today is Guillaume Roger from the Monash University Grid Innovation Hub.
Hi Vic.
Tell us, Guillaume, what is the research that the Grid Innovation Hub is working on at the moment?
Yeah, thanks Vic. So broadly speaking, we work on questions that pertain to the energy transition, be they engineering problems or economic questions. For example, my colleague Biruz is a power system engineer, works specifically on weak grids. I'm an economist and I'm interested mostly in storage integration in the national energy market, the NEM. When it comes to storage, we want to understand what are optimal strategies for storage operators because we'd like to exploit those optimal strategies in designing market rules that are efficient for consumers. In itself, this problem is not new. Market design has been around for a couple of decades now. What is new is the complexity of those trading strategies that storage operators can use. We also work on eliciting better forecast information from renewable operators. In this instance, for example, we want to design proper incentives for better forecasting and reporting of that information.
That sounds relevant, and this is what drives our collaboration with the Monash University Grid Innovation Hub. PSC being a specialist engineering consultancy firm, we work on practical applications that deliver solutions for the energy transition. And what are the practical applications of the research that you're doing?
So we think there are many such applications that are relevant to multiple parties in the NEM. For example, a market operator today has the job of cost minimizing the dispatch, which they do so by pricing and repricing every 5 minutes. The problem with that is that this is a myopic exercise, but storage is not myopic. So we think there's room for the market operator to improve the performance by considering a longer time horizon for engaging in their cost minimizing dispatch. That extends beyond the market operator. It could be also private operators. So for example, when it comes to developers and operators of those units, developers would like to understand and value those cash flows, which they only can do if they go down into the weeds and understand how those units are really operated.
For investors and financiers, how would this apply to them?
So that's a good question. These guys are really the counterparties to developers. So they have essentially the same vested interest in understanding how those units are being operated. And from the operational model, then it's quite easy to take the step to write a simple financial model to value those cash flows.
Are these impacts the same globally, or is this just for an Australian context?
So the nature of the work that we do is really agnostic as to geography or technology. So it really can apply to a lot of different locations and a lot of different storage kinds as well. It's mostly relevant to jurisdictions where you observe a rapid uptake of renewable energy, of course. So Australia is a case in point, but there are others. In fact, Australia was very much leading the way when it comes to storage with the installation of the Hornsdale Power Reserve. Since then, jurisdictions like California and Texas have leapfrogged ahead of us in terms of storage installation, probably because they've been propelled by government programs that we have not benefited from here. In addition to these government programs, importantly, markets like California and Texas also benefit of what's called nodal pricing, which is really beneficial to storage operators.
And what about Europe?
So Europe remains a bit of a question mark for me for a couple of reasons. The first one is that except in Southern Europe, there's very limited scope for solar generation in Europe. And here we're really talking about the Iberian Peninsula mostly. The second part is this needs to be accompanied by storage, and storage takes a lot of space, and space is very expensive in Europe.
Where have you identified the challenges that arise in the research so far?
So the one observation I make is first that storage operators seem to be employing very simple strategies to date. So they've not really embraced the extent of the complexity of the object that they're trying to work with. Beyond that, the main concerns that I have really fall under the banner of what's called competition policy. At present, there's a handful of storage units that are owned by essentially one of the three gentailers, either outright or through contracting. And the problem with that is that we run the risk of seeing them transferring the market power that they have in generation onto the storage market. So we need to be very vigilant to make sure that there's further entry by independent operators, to provide sufficient competition to those gentailers. We also think the current market design is not really appropriate. In particular, we think the zonal pricing is a problem, and nodal pricing supported by financial transmission rights will be a very good improvement over the current status quo. The one thing I would say that we are not concerned about is volatility, even though people talk about volatility all the time. And the reason is that storage feeds on volatility. And in the exercise of buying and selling really counters volatility in the first place. I'm going to add one more thing, which is that I think the big elephant in the room that no one really wants to hear about is the true cost of the energy transition. There's a false narrative out there that suggests that renewable energy is cheap. It's true when you don't have to store it. As soon as you have to add storage costs to that becomes a very different proposition. Storage is really where the big investment needs to be made. And here we're talking hundreds of billions. It's a lot of money.
That's very, very interesting. What's next for the project?
So first, I'm an academic, and so I'm going to argue my point and say, or argue my cause, I should say, and say that more research needs to be done. More concretely, we really need to make progress on market design with storage. We are working now in that direction. This is a difficult exercise. And the second part is, if we take the proposition seriously of a full energy transition, that means there'll be no thermal generation in the system anymore. We have to ask the question, what does the market look like in such an environment?
What other solutions to the electricity industry challenges that you and your team are working on in your projects?
Right. So most of what we do really centers around the energy transition, and it turns out storage seems to be very central to that. So for example, my colleague Birouz Barani works a lot on what's called inverter-based resources. And on trying to make the best use of it. He works on projects that have to do with dampening oscillations, for example, frequency oscillations on the network. But there's also more speculative and more exciting stuff to work on when coupled with storage. So for example, we know very well that you can couple storage units to IBR and then deliver grid support services. This is already done. I think the horizon is that we can even improve on that. That is, with IBRs, you can only mimic the inertial response, you can even improve on it. I think that's an exciting development.
That sounds like there's much more to come for the team. If other like-minded partners would like to get involved, how can they do it?
Oh, by all means, we always welcome new partners into the Grid Innovation Hub. There's a lot to do. This is a multidisciplinary research team, and so we encourage people of all sorts of backgrounds to join us.
Thanks, Guillaume, for the update on the research so far. Watch this space, everyone, as the journey is just beginning.